Loan schedule. So let's do this question. A loan of 50,000 is repaid over 10 years by a series of level monthly installments. Interest is charged on the loan at the rate of interest of 8% per annum effective. Calculate the monthly repayment. Calculate the amount of interest paid in the first year. And after the payment at the end of 7 years, the borrower takes a 2-month break. That is, the borrower does not pay the next 2 monthly installments. Calculate the extra amount that needs to be paid each month in order to fully repay the debt by 10th year. So we'll open a new document. Okay, and now we'll start writing our question. So question 1, part 1 is our let P be the monthly amount. Okay, monthly repayment, working in years, we are getting alt equals to 12P, and in its arrears, so alt shift B as we know, and we have to pay it by the 10 years. Make sure you're on N. 10 to the power 12. Remember, I told you, right, to the power 12, this goes up. Okay, 12 in brackets, there should be double brackets when you write 12. Okay, is equals to 50,000, where we just write I is equals to 8%. Okay, and then we get what? P is equals to 50,000 divided by 12 into 6.9527, which is equals to 599.29. Okay, we have calculated P. Now part 2 said us calculate the amount of interest paid in the first year. So we'll calculate the amount of interest paid in the first year. So we'll work prospectively. First, amount outstanding at the end of first year is, so alt equals to 12 into 599.29 into brackets close, again alt shift B, putting this 9 to the power 12, again 12 in brackets. So these things you have to be careful every time when you write it. Okay, that you have to put double brackets in one so that you don't have to come back. At the rate 8% is equal to 12 into 599.29 into 6.4728. So this calculates to 46548.71. Okay, therefore capital repaid in first year is equals to alt equals to 50,000 minus 46548.71, which is equals to 3451.29, and interest repaid in the first year is equals to 12 into 599.29 minus 3451.29, so which is equals to 3740.19. Okay, so this is the interest repaid in the first year. Next part, after the payment at the end of the 7 years, the borrower takes a 2-month discount. So here a 2-month break he is taking, and the borrower does not pay. Calculate the extra amount he needs to pay each month in order to fully repay the debt by 10th year. So part 3, come down. So now part 3. For part 3, amount outstanding after 7 years is equals to 12 into 599.29 all shift B, and then remaining years is 3, okay, to the power 12, and then this is equals to 12 into 599.29 into 2.6703, which is equals to 19203.25. okay. Once you solve this, as no payments are made for the next 2 months, capital outstanding after 2 months, so no payments for next 2 months, capital outstanding after 2 months is all equals to 19203.25 into 1.08 to the power 2 by 12, which is equals to 19451.15. okay. This is to be repaid in equal monthly installments, so let Q be the monthly installment. Let Q be the monthly installment, okay, over the next 2 years and 10 months. So therefore 12 into Q into all shift B, this has to be equal to 2 and 10 by 12. So 2 space give 10 by 12. So this becomes 2 10 by 12 and come out then to the power double brackets 12 space, this becomes equals to 19451.15. okay. So therefore alt equals to Q is equals to 19451.15 divided by 12 into 2.5375 is equal to 638.78. Therefore extra payment is 638.78 minus 599.29, which is equals to 39.49. okay. So this completes the first sum. Next, coming down to second sum. Coming down to second sum, we have a man borrows 7,500 to buy a car. He repays the loan by 24 monthly installments of 368.75 payable in arrears. Calculate the APR on this transaction. So we need to calculate the APR on this transaction. So this is also material sum. If you see, I have taken the sum 11.6. So we'll just do this here. APR, let APR be I. Okay. So therefore 12 into 368.75 all shift B, which is there, this n has to be 2, and again to the power double brackets 2 which is a half yearly 12, which is a monthly payment. This has to be equal to 7,500. okay. So therefore alt equals to, you see, A2 to 12 is equals to, if you see, you calculate, this has to be equals to 1.6949. We have calculated this, and then what they have said is you can just try it by interpolating, and now in your, so by interpolation, we just do interpolation using calculator. You can, by interpolation in calculator, you will see the values to be 17.7%. This you don't have to write in copy also, directly you can see the values. Okay. No need to do calculation also. Next for question 3. Coming down. A loan is to be repaid by payments at the end of each of the next 15 years. The first payment is 100 and the payments increase by 20 per annum thereafter. Repayments are calculated using a rate of interest of 5% per annum effective. Calculate the amount of the loan. So we first need to calculate the amount of the loan. Therefore, so let's do the first part, question 3, part 1. So we have to calculate the outstanding loan. So amount of loan, let L be the amount of loan. Okay, and then therefore alt equals to L is equals to 80, alt shift B again, and then this N has to be just the N. Okay, just the N has to be 15 plus 20 IA 15. So again IA 15, how we had saved it, alt shift E was IA. So you don't have to waste your time on writing. Just change the N value. You will keep on doing this. So therefore alt loan is equals to 80 into 10.3797 plus 20 into 73.6677. From the tables you need to write. So 2303.73. And write from the tables. Okay, so this is done. Next part says us set out a loan schedule showing the capital and interest payments in and the amount of loan outstanding after the 6th and 7th repayments. So again part 2. So first you have to calculate the capital outstanding after the 5th payment. After 5th repayment. So capital outstanding after 5th repayment is alt equals to 180, and then we'll just alt shift B. This now remains to be after 5th payment. Now this becomes 10 and plus 20 alt shift E, and now this becomes 10 also. Okay. So solving this, 180 into 7.7217 plus 20 into 39.3738, which is equals to 2177.38. Okay, so and now this, so therefore interest element of 6th payment is 0.05 into 2177.38, which is equals to 108.87. Okay, and capital element is equals to 200 minus 108.87, which is equals to 91.13. So therefore capital outstanding after 6th repayment is equals to 2177.38 minus 91.913, which is equals to 2068.25, 2086.25. Once this is done, same thing, interest I'll just copy this so that I can just change the values instead of wasting my time. So interest element of the 7th payment is 2086.25, which is equals to 104.31. Capital repayment is again 220 minus 104.31, which is equals to 115.69, and capital outstanding after 7th repayment is equals to 2086.25 minus 115.69. So this is equals to 1970.56. Okay, once this is done, we'll just create a schedule for us. So this is how, since the question says set out a schedule, so you can go to insert tab, table. How many columns do you need? 1, 2, 3, 4. So we'll take insert tab, go to table, you need 4 columns and you need 4 rows as well. Payment, interest element, capital repay, and capital outstanding after repayment. Okay, so 5th, 6th and 7th we need. For 5th we had got is 2177.38. For this one we got 108.87. Use tab 91.13. Then we left with 2086.25. Tab 7th repayment we have 104.31, 115.69 and tab 1970.56. Okay, so this is how we do these values. Okay, there is one more way which I can show you all how to do this, how to construct your answers is, go to Excel, just write, since we have been told we can use Excel to construct the answers, you write your loan amount. So if you see coming up, let's see here, easier to see, loan amount was what? We had calculated 2302.73. So 2302.73 is our loan amount. I is given to us as 5%. So you need to do this. N is 15 years. So therefore, and X is 200 increasing. X is 100 increasing by 20 each year. So we have our year, we have our loan outstanding at the beginning of year, we have our installment, interest, capital repay and loan outstanding at end of year. So this is the there. Now we'll just fill the series fast one. So this comes down, columns, top value becomes 15, loan outstanding is equals to this value, installment is 100, this remains fixed, plus it's increasing by 20 into time minus 1, right? So 20 into time minus 1. This is how it is increasing. Interest is this into loan outstanding into the 5% which remains fixed. Capital repaid is equals to loan installment minus interest, and loan outstanding is this minus this. Okay, now for this year it is this value. We'll drag this down. Each year this increases. Okay, now if you see that we had calculated, we had calculated 2177.38. We are getting 2176. This is because of rounding of error and nothing else. If you see, the payments are same, 1080 and 91.19 and so on, and 2084, which is, these are all rounding of errors, which doesn't matter when you are using this. What you could have done here now is just give a border to this Alt HBA. You could have copied this in Word as it is, solving the entire thing instead of doing in calculator, and then put the, obviously put the header also here. So say I'll just write insert row above. So here you can again put your loan outstanding at BOY, that is beginning of year. This is installment, interest element, capital, and loan outstanding at EOY. So once you are done with this, you can do, what you can do is you can just write that loan outstanding in year 5, or say year n-1. You can just write that, and you can just write this formula and go on. Okay, just write this equation, and then you don't have to show your calculation, you can just write the values. So what is it? You can just write loan outstanding, and you can just write this equation. Loan outstanding in year 5 or capital outstanding is equals to this, which is equals to 2176.116. okay, and then you can show the same way, the way we have written these values, we'll just write this, and instead of calculating we can just do the calculations in Excel. Okay, so whatever suits you. If you all think this is okay, you can use this. If you want to solve in Excel and paste the table here, this is also okay. Anything which you feel comfortable is okay. I've showed you both the methods. Next is calculate the capital and interest in element of the last repayment. Now if you see, this already we have calculated of the last repayment 17.9969. What you have to do is you have to just write. So part 3, so loan outstanding at last year. So I'll just paste this. We were left with this, and if you see, the last installment is how much? 380. See, they have written 380, and they've just written 380. This is 361 point, just minus, because you need to calculate you need to calculate the capital and the interest payment. So if you see, the last payment is 360, working prospectively 380, this is 361.90. This must also be the capital element of the last payment if the amount is to pay off the loan. Thus the interest element is 81 point this. So what we can do is you can just write your value, which is, instead of writing this whole equation, so you are left with only 380V, which is equals to 361.90, and you can write, therefore the interest element is equals to 380 minus 361.90, which is equals to 18.10, and capital is 361.90. You can see it from the table as well. Okay, closer values. This is just a rounding of error which we are facing in Excel. Clear? So this is how you will do the sums when doing loan schedule.